So access control lists, commonly referred to as ACLs. ACLs. So many technologies and protocols depend on ACLs. One of them is what we just looked at, which is called network address translation. It actually depends on access control list. Whenever you want to configure easy IP or network address port translation, you need to create an ACL first. So they depend on ACLs for greater management and filtering of traffic as part of security measures or application requirements. The implementation of ACL in support of other technologies and as a form of security are required to be understood by you network engineers. And as such, common forms of ACL solutions are introduced in this chapter. By the end of this chapter, you should be able to, Oyo,
describe the application of ACL in the enterprise network.
yes,
Explain the decision-making behavior of access control list.
yes, very important.
Successfully implement basic and advanced access control
Yes,
list.
asante. Okay, just a moment. Okay, so ACLs can be used in one of two ways. The very first way ACLs can be used is to filter traffic in your network. To filter traffic. Filtering traffic is controlling the access of certain resources within your network. That is what filtering traffic is. Now, for example, here we have two networks. Let me call it the red network and the blue network. So for example, the red network might be your students network, while the blue network is your finance department network. So you want the finance department people to be able to access the finance server. So they'll be able to access it. You'll filter that traffic, but you don't want students to be able to access the finance server because they can hack it. So you filter that traffic. Where do you filter? In your router. You configure an ACL. On the other hand, you want students to be able to do their research on the internet, but you don't want the finance department guys to Facebook and YouTube when they're supposed to be working. So that's the very first thing that ACLs can help us do, to filter restricted traffic. Okay. Other than that, it can also be used to filter what we call interesting traffic. So other than restricted traffic, we have interesting traffic. An interesting traffic is a traffic that you need to apply some additional operations on it. Now, let's look at this example. Again, here we have two networks. The red network, let's call the red network the students network, and the blue network, we call it the management network. So really, you want the information that is sent over the internet from the management, you want it to be encrypted, because they are most likely engaging in sending sensitive data. So you want that data not to go as plain text. You want it to be encrypted. So in your router, you're going to configure an ACL. If the rule matches, then the data is encrypted. If the rule does not match, for example, for the student network packets from the student network. If there's no match, then we just forward you normally. So these kind of data, who we need to perform, we don't really need to either permit or deny access, but we just want to perform extra operation on it. That kind of information is what we call interesting traffic. Interesting traffic. So packets can be filtered to manipulate behavior and actions. So parameters and forwarding behavior can be altered as a result. Forwarding behavior such as encrypting the data. Parameters for protocols such as OSPF, RIP, we might change the parameters like the priority and so on and so forth. Okay. So those are the two applications of ACLs in general. Now, we have three types of ACLs. The very first one is called a basic ACL. A basic ACL, when we create an ACL, we give it an ID. Now, the ID is used to uniquely identify that ACL. So for basic ACLs, we are supposed to use an ID between 2000 and 2999. Basic ACLs use a single parameter. In order to filter the packet. That parameter is actually the source IP address. Then you have the advanced ACL, uses an ID between 3000 and 3999. Parameters, you can use a combination. Source and destination IP, you can use the protocol. Packets from this protocol are not allowed, or source and destination port numbers. So for example, you can block port 80 in your router so that any packet whose destination is to a TCP port 80 is simply discarded. Then the last type of ACL is known as a layer 2 ACL, and as you might have already guessed, Layer 2 ACLs filters traffic based on MAC addresses. It uses an ID between 4000 and 4999. So generally, the three forms of ACLs can actually be applied in the AR2200 series. And parameters for packet filtering is what varies in each type of the ACL that we've seen there. So let's look at now what we call ACL rule management. There are a few points here that you must understand in order to be able to tackle the exam. So make sure you are alert on this one. Now generally, ACLs use what we call ordered rules. It uses what we call ordered rules in order to filter traffic. These ordered rules will have either a deny or permit clause. A deny or permit clause. Now, with the AR2200 routers, it supports two types of what they call matching order. Now these two types, the first one is called the configuration order, and the next one is called the automatic order. The configuration order evaluates rules in ascending order of the rule identifiers. So every rule has an ID. in ascending order of the rule identifier. On the other hand, automatic order uses what we call a depth first. We're talking about depth first search, something like that. So depth first principle that allows more accurate rules to be matched first. I also don't know how it works so far, but generally the configuration order is the default matching order for Huawei routers, the configuration order. So it assesses the rules in ascending order of the rule identifiers. Now for each rule ID, the ACL will determine if the rule applies or does not apply. And if the rule does not apply, then it will check the next. It will check the next rule. On the other hand, if the rule matches, then that rule is implemented. That rule is implemented and the ACL stops. It doesn't look at the other rules. If no rule matches, if all the rules are evaluated and no rule matches, then the router will go ahead and discard the packet. Now, what I've just said, let me now give you this particular example. So we have the red network here and the blue network. So in this router RTA, we've created this ACL. So let's go one by one. So the ACL, we've created ACL 2000. ACL 2000. Now, in this access control list, we will have many rules. So for example, here, the very first rule is rule 5. So this is the rule identifier. Rule 5, it has a deny clause. We said it can be deny or permit. So what is this one doing? Denying. What is it denying? Anyone with a source address from this particular network, 192.168.1.0/24. So if a packet comes in and the source address lies within that network, discard it. So that is what rule 5 is saying. So if that rule does not match, then this rule is going to be considered. It's going to be evaluated, the next rule, in ascending order. So you see, this one has a rule ID of 10. So from 5 to 10. Again, this one has a deny clause. And the source, we are saying, anyone with a source address from this network, deny, discard the packet. If that does not match, I go ahead and look at the next rule. So rule 15, again, has a deny clause. So what are we saying here? If someone has a source address from this network, 172.16.0.0/24. Who is that actually? This guy, anyone from this network. So if anyone has a rule from that network, discard that packet. Now, if, for example, a packet is coming from the red network, the rule 15 will match. When rule 15 matches, the packet is discarded and the ACL will not look at the next. It will not go ahead. It will not go ahead and look at this rule. It will simply discard the packet and stop looking at the other rules. So whenever a rule matches, we stop looking at the ACL. We stop processing the ACL and perform the action that rule which has matched is actually saying. Now, let's go ahead. Now, for example, so far, no rule has matched for a packet that is coming from the blue network. So far, no rule. We have no rule that matches packets that are coming from this network. Now, at the very end, the very last rule is recommended that you always configure it as the very last rule, and you put a permit clause, and you allow any. So source any. So this very last rule will allow any other packet that has not matched on the other rules to actually be allowed to be carried forward or to be forwarded by the router. Otherwise, if you lack this clause, any rule that does not find any match in the ACL and you don't have this clause, permit source any, will simply be discarded. Will simply be discarded. So in summary, rules are used to manage the decision process for each access control list. For each access control list. So I hope that is clear. Please, when you get time, read the notes on that particular slide and make sure you understand every bit of it. You can't miss a question about ACLs in the exam. Okay, so basic ACL, how do we configure it? So in RTA, we want to configure an ACL. So we create a basic ACL using that value range. So this one, you're calling it 2000. We'll get into that particular ACL view, ACL 2000. Then we can specify rules. So rule deny source, then rule permit source. So what are we doing? What are we doing here? So with these two rules, we are simply saying host A will actually be denied. Packets from host A will be dropped when it's trying to go out this interface, because that is where we are applying here. We are applying on that outbound interface. So traffic filter outbound, we apply ACL 2000. So any packets from host A will simply be discarded. On the other hand, the next rule is rule permit source 192.168.2. So host B here belongs to the .2 network. So generally packets from host B have been permitted. So this guy can be able to access the internet. And as such, they can be able to access that particular server. So that is an example of a basic ACL. Remember, with a basic ACL, it only uses the source IP address. The source IP address. So we can always validate. Let me just show you something. When you're creating rules, you can remember the rule identifiers. Like here, we have rule 5, rule 10, rule 15. Those rule identifiers are referred to as the ACL steps. The ACL steps. So you can actually specify when you're creating the rules. You can specify the steps. For example, here, instead of just saying rule then deny, you can say rule 5 then deny, like that. Here, rule 10 then permit. But when you don't do that, we usually have a default step value. A default step value. So for example, here, you see when you say display ACL 2000, we can see that we have configured two rules so far. And you can see that the ACL step is 5. The ACL step is 5. So that means anytime you create a rule, the rule identifier is going to be incremented by 5. So in steps of 5. So if I create another rule, it's going to be rule 15, then rule 20, then rule 25, then rule 30. So that is what the ACL steps actually achieves. So from host A, as you can see from the red network, if you ping the server, your request is going to time out because we've denied you from accessing that server using the ACL. And that's why when we click here, when we do display ACL 2000, we can see that on rule 5, we have 5 matches, because when we did the ping, 5 ICMP requests were sent out, and all of them were discarded, and it was captured. So far, we've had 5 matches on this particular rule. Advanced ACL. When you're configuring advanced ACL, remember you can use a number of parameters rather than just the source IP like in basic ACL. You must use a value range between 3000 and 3999. So this time we are using 3000. Then here, this is the same command up to there. So we're just saying that the clause is a deny clause, and we are checking the TCP protocol on the source address. If the source address is coming from this network and the destination is this. So here we are using the source and the destination. So we are using the source address. If it's coming from that guy and going to this guy, then deny it. And you're also looking at the port. Via which port? Via the destination port 21. We know port 21 is for FTP. So if you're trying to access, in this particular example, you're simply saying, if you're on this network, who is on that network? Host A. So this guy with 192.168.1.1. If you're from that network and you're trying to access 172.16.1.16.10.1, so you're trying to access our FTP server on port 21, then we will simply deny. So the router will check and discard that packet. So that is what that rule is saying. The second rule here in ACL 3000 is using yes, Oyo?
I want you to help me somewhere here.
Yes.
If you view the rule destination, the destination IP address is 172.16.10.1. Then if you check the sub mask is .0.0. Why are we using that? But
okay.
From there I can see.
Okay, thank you very much for that question. Actually, that is very important. It's good that it has come up now. Thank you for observing that. So generally, we have this IP. You see, this time we've specified a particular IP address, the exact IP address for the server. Are you seeing that? We've not, for example, specified a network address. You see, like for the source, we are specifying a network address. We are specifying 168.192.168.1.0. Then we are using an inverse mask 00.255. Are you seeing that? Are we together up to there? Guys,
We are together.
are we together? Yeah?
Yes, we are together.
Okay, so I want to show you. I want to show you how ACLs actually make decision using the inverse, mask. Eh? So using the inverse masks, what it does is this: everywhere on the mask, on the wildcard mask, everywhere we have a 0, the IP address must match at that particular point. Everywhere where we have a 0. So for example, if we convert, every bit must match. So actually we're supposed to convert this into binary and this into binary. Eh? So every bit must match. So everywhere where we have a 0, it must match. So for example, that must be 192. The next one that must match is 168. The next one that must match is 1. Now, where we have ones, for example, 255, if we convert 255, we will have all ones. So where we have ones, then it is not a must for that particular value to match. So this particular value can actually range all the way from 1 to 254. So that's why this particular rule that has that will allow all these IP addresses 168.1.1, 192.168.1.2, 192.168.1.3, all the way to 192.168.1.254. Sijui kama mmenipata hapo. Have you understood what I'm saying?
Yes.
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 So thank you. So that means that. So now let's go to this specific one for the server. So for the server we have 172.16.1.1. We only want to restrict access to that particular server and not to other addresses. So the mask we use is 0.0.0 so that the match can be exactly for that specific server. Are you getting the point? So is that clear now, Oyo?
Yes, it is clear now.
Okay, wonderful. Thank you for bringing that up. And expect a question, by the way, that will need you to use this, whatever I've just told you here. You'll need this knowledge to be able to answer ACL questions in the exam. I almost forgot to bring this up again. Thank you, Oyo. So I think the next rule there is something that you can be able to interpret. Then after you've done all the rules, you need to apply that ACL. This time we're applying the ACL in the inbound. So this is called the inbound, this is called the outbound interface. So why is it called the inbound? Because when packets are moving from here, they get into the router through that inbound interface, and they get out from the router to the internet or from other networks or to other networks through that. So that's why this is called an outbound interface. This is called an inbound interface. So you can apply ACLs on whichever interface that you deem appropriate. So we can confirm our configuration by typing display ACL 3000. You can see we have two rules. By default, the ACL step is 5. So we didn't specify the step, but we have rule 5 and rule 10. And the other information you should be able to understand. This is something we did. We already did this in the previous chapter, how to apply ACLs in NATing, in network address translation. So this is another example of applying what we called interesting traffic. So you don't, you really don't want to deny or permit, but you want to perform an act. So we already know how that is done. You're going to do it in the practical. So I'm not going to go through that again. And that is it about ACLs. So can I have someone go in for the first question, a volunteer? Then another person picks the next one. Anyone who's not talked today? Anyone we've not heard from?
It's Joshua.
Joshua. Okay, go ahead, Joshua.
The advanced access control list is capable of filtering traffic based on which attributes?
Yes.
We have the protocols, the source and destination port number, and the source and destination IP.
Yes. Yes, thank you very much. Next. Anyone else we've not heard of? Nicholas, are you there? Bethwell or Benson?
Okay, once an ASA rule is matched to a condition,
yes, Chris.
What action is taken? The rule is applied and it does not go further beyond that point.
Exactly. So that rule is simply implemented, and the ACL is no longer executed. We don't go to the next rule. We simply stop rolling through the rules. Thank you very much, Chris. Asante sana Joshua. Asanteni nyote.